Welcome back to another SRP Lunchtime webinar in partnership with AURPO. Today's webinar is on warning signs and lights in veterinary practice. As always, I'll just go through the ground rules before we start. So questions, as always, will be asked at the end of the presentation. You can use the Q&A box. You can also like any questions that appear in that box, and the most liked at the end of the talk will be posed to the presenter. For CPD points, we've got another code here on the screen. We'll also post that into the chat box as well. If you email that to admin SRP email address to register your attendance, you'll get an email back so you can claim your CPD points for attendance today. And as always, please send us your feedback. We'll send out an online survey link after the webinar. So if you could fill that in for us, that'd be really helpful. Thank you. Just to plug, if you've not seen it already, that the second issue of Radiation Protection Today is out, and you can find that on the website there. And lastly, if you're not a member of SRP, then I'd just like to remind you of the benefits that you could get if you were a member. So we've got the Society Journal, a weekly e-newsletter, discounted attendance at conferences, you get access to job vacancies, you can also get involved with SRP committees, and you can look at registering for professional statuses, which if you go onto our YouTube channel, there are a couple of videos on there about what they are and how you can apply for them. So without further ado, I will pass over to Professor Pete Cole. He's an SRP past president and the current AURPO president. Over to you, Pete.
Thank you, Sarah. Welcome everybody to another SRP AURPO lunchtime webinar. And just before I introduce today's speaker, I would just like to remind people or highlight to people that the AURPO annual conference this year will be a real conference, if that's the right expression, face-to-face in Liverpool on the 6th and 7th of September this year. As I say, Liverpool, maybe I'm a bit biased, Liverpool is a great city for a conference, and we have a great prospective programme of talks for that conference in preparation, if not already planned. There was a great social calendar as well. We had a couple of great social events, one of which will be the conference dinner, which will be held at the iconic Royal Liver building overlooking the Liverpool waterfront. So I'll just ask you to make note of those dates, and I hope to see as many of you there as possible. Thank you. So with great pleasure, I will introduce today's speaker. Neil Pearce has been an RPA for 40 years. He's always had a particular interest in all aspects of radiation protection in veterinary practice. He's been a member of SRP since 2000 and became a fellow in 2020. Neil is currently the CRADP Secretary for Professional Registration for SRP. And today he's going to talk to us about warning signs and lights in veterinary practice. Over to you, Neil.
Hi. Just sharing the screen. Right, are we the correct way round with the slides not seen?
Yes, looks good, Neil.
Great. Right, there have been many issues with warning signs and lights in veterinary practice, and I hope today to try and set a standard across the board. There is legislation in force that determines the colour, the form, everything about warning signs, signals, that is lights and other devices. First thing to look at is the colour. The colour of signs and lights is not interchangeable. And the actual colour, I can put a copy of this, but the blue, red, yellow and black codes are specified in the regulations. Yellow is a warning sign, red prohibition, blue is mandatory, and green is information. The symbols that go with these signs, a lot of work has gone into those, and again, there are a set number of symbols that are used. You can't make up your own. For instance, the skidding on this one is impossible, but a lot of thought has gone into the visual impact of that. And if you compare it with just a normal skid, I think you'll agree that the one they've come up with is much more impressive and more easily noticed. A common incorrect sign forbidding entry into a controlled area is this. You can still use it, it means no pedestrian access, but the actual sign is a no entry. I came across this one not long ago. They only had a black and white printer. And you can see it doesn't have the same impact as the coloured one, and it's against the regulations. As is this, which I took off the door of a vet's X-ray room not long ago. So, signs must mean what they say and say what they mean. Very few people actually read signs. These were distributed by X-ray suppliers and reps and all sorts of people back in the 80s. And this means one thing and one thing alone. When their red light is on, they can't go in their X-ray room. Full stop. When this sign is displayed, with or without a light, no one can go in the X-ray room. These, unfortunately, are stuck to walls and doors with the most tenacious adhesive I've ever come across. They are difficult to remove, but they can be covered up or whatever. These are recent examples. As you can see, the ones with the red lights on, these forbid any entry into those X-ray rooms when the red light is on. But nobody takes any notice of that. So also, we'll come on to it later, but there are contradictory signs there. Some say entry to authorised persons, some say no entry, some don't mention lights. But they're just ignored. I often hear the justification, doesn't apply to us, we've got to go in there, it's to keep everybody else out. So I've drawn up a sign for these people, and I think you'll agree that that's not really an appropriate sign. Also, I've been doing it like that for 20 years. Why this sudden change? Well, warning signs and signals regs came in 26 years ago, and it's up to employers to get advice on what regulations apply and apply them. In every practice I've worked in, they've done it like that. The answer to that is, so what? There's no excuse for not doing it right. So the signs must be informative. They must address a risk. They must tell you something useful and be ambiguous. I've come across a number of these. What does that sign actually mean? It should be black on yellow, and the sign at the other end of the road is black on yellow. But the only purpose of this sign is to, as far as I can see, is just distract drivers who may drift onto the other side of the road and hit another distracted driver coming the other way. It has no useful purpose whatsoever. You can see why this one's taken down, but it doesn't tell us anything that we don't know already. Ambiguity. Does this no parking apply to residents, or is it residents it doesn't apply to? Just a simple rewording makes it clear. So signs must be immediately clear as to what they mean. I drove up to this thing and I had to pull into a side road and try and figure out what on earth I was supposed to do there. And I Googled it, and it's a very useful arrangement, but it's not immediately obvious what you do there, which makes it a very bad sign. So signs must display everything required. I find many of these in practices, it doesn't tell you enough. It doesn't tell you what sort of radiation. It doesn't tell you what sort of PPE is appropriate. It doesn't say whether it's alphas or gammas or whatever, and might as well not be there. Again, so it's a controlled area and there's some sort of radiation in there. Radiation risk, again, what risk? What radiation? What level of radiation? Unsealed source, sealed source, X-rays, betas, alpha, whatever. It doesn't really tell you enough. And we're getting a bit better now. It's a controlled area, it's X radiation, and hopefully another sign would expand on that. Again, taken from a recent practice. So we've got a red light. I don't know what it means, and nobody else does. It's not telling us anything. And again, radiation risk. What's the risk? If you don't know what the risk is, then you can't deal with it. So as a bare minimum, you want to state that it's a controlled area, state the radiation, and give the details of the RPS. This can be expanded, contact numbers of RPA and RPS, who can go in there, and when is it a controlled area, and the light that describes when it is a controlled area. There's no such thing as a generic radiation sign. They should be tailored to what the situation is. For instance, controlled area when the yellow light is on, when the warning light is on, when the sign is displayed, when the X-ray machine is connected to the mains. They all expand on the information that is required before you go into the controlled area. Similarly, information can be given on these signs and should be given. Dose meters, PPE. Do you close secondary doors into the room? Do you lock them? Do you lock them when the warning light is on? You can't send off for a door shut sign that applies to every practice. And incidentally on this, if you have a sign that says dose meters must be worn and dose meters aren't used, then you're contravening the regulations by going into that controlled area without a dose meter. So signs must apply to the actual situation. Similarly with red signs, no entry when the red light is on, authorised entry only. No entry when this sign is displayed, authorised persons when the yellow light is on. You can't just send off for an X-ray warning sign and expect it to match your particular situation. These are all combined, well, what I refer to as combination signs. So from here, there's a controlled area with X radiation in it, demonstrated by a yellow light being on. When the yellow light is on, authorised persons only are allowed to enter. They must wear dose meters, and in this case, possibly it's a fluoroscopy room or equine. Wear your PPE before going in, or it might say appropriate PPE must be worn during exposure or if remaining in the controlled area. But each of these refers to a specific situation or a door that you don't want anybody going through. Must be closed when the red light is on, and full stop, you don't use that door. These can be a bit extensive, but this is fair enough, but the more signs that are displayed, the less people will read them. So they need to be kept to a minimum. Must be prominently displayed and easily seen and read. This is a common situation I come across every time I send an updated sign. So they changed the colour of their light or they've added a light. I send a replacement sign. Vast majority of practices just put it up as well as the previous sign. So you have a mixture of signs saying, do not enter when the red light is on. They don't have a red light. Controlled area, when the red light is on, they have yellow lights. They don't apply to the situation at the time. And as an example, this is just a mess. It's not immediately obvious that there is actually a warning light there, but your eye isn't drawn to it, and it's just a mess. Similarly, you get a new sign and you put it up. No matter how contradictory they are. People don't read signs. Isolator signs are rarely used, but essential. If there's a fault, how do you isolate the X-ray machine? Does anybody know that the consumer unit's in the nurse consulting room? And you can add other appropriate signs to this. And each one is specific to your practice. I once had to draw up one of these signs and phoned up the practice because I didn't know where the MCU was. And the receptionist said, I'll see if I can find anybody that knows where it is. And they came back a few minutes later saying, nobody knows where it is, but the boss is in tomorrow. If you ring up then, he'll be able to tell you. So you have Gladys being electrocuted in the X-ray room, and ludicrously you have to say to her, the boss will be in tomorrow and we'll be able to switch the power off. It's not good enough. So where the main consumer unit is, where the isolator is, the actual isolators are marked by a sign, and the one with the arrows in goes in the main consumer unit, and points to the X-ray isolator. So some practices have 20 or 30 circuit breakers, so indicating which is the one to shut off the X-rays is vital. If it's complicated to describe where the isolator is, for instance on this battery controlled X-ray machine, then a picture that everybody can see indicating where the isolator is a great deal of help. In the main consumer unit, at a glance, you wouldn't know what circuit breaker did what. So the sign indicating it straight away is invaluable. Whether these signs should be green or red is debatable. Emergency stop is information, so it's green and white. But you might call it red and white because you're stopping something, but I would favour green. This is a plan view of a controlled area with the isolator at floor level behind the table next to the X-ray head. So I'm looking through the blue window there. No isolator outside. So if anything goes wrong, if it goes into continual exposure or it starts discharging high voltage electricity, it's rather nice to be able to know where the fuses are, where the switch boxes are, where you shut that thing off without going into that room. It's widely thought among some people that it doesn't matter what the colour of the lights or the colour of the signs is, provided that their function, their use is described by an accompanying sign. So this one here, personally, it makes gives me a headache. When it first comes up, all the brain reads is entry on the green, and then a few seconds later, the no comes in. This is ridiculous. You have to use the right colour. And just in case you think that this is pedantic, this is an actual veterinary X-ray room, and the brain looking at that reads enter. A green sign doesn't register as stop or no entry. The brain reads sentences, not words. So this classic exercise reads Paris in the spring, because that's what the brain reads. Until you actually look at it word for word, and you see that it actually says Paris in the spring, then it gets an obvious, but at a glance, the brain just reads that sentence. This means you can turn left, but the brain recognizes it as no left turn. What does that mean? Again, the brain picks up the meaning, even if it's wrong. So signs must be appropriately worded and be realistic in what they're asking you to do. This is a classic, and it's not a real one, but this is The fire door, keep shut. Fire door, keep shut at all times. You can imagine a crowd of people standing outside it, running away from a fire and not opening the door because it says keep shut. Again, this was taken from a hotel in Wales. What they actually mean is this is an emergency exit. Do not use it to nip into the car park. But what it says is don't use it. So lights and signs must be consistent. Restricted entry when the red light is on. This is fine, provided that this refers to just one room in the practice and everybody knows what it means. If you have different rooms, for instance, fluoroscopy, you have yellow lights and red lights. The red lights mean no entry. The yellow lights mean a controlled area exists. Same with a CT room. And if they're signed and have lights like that, then the main X-ray room should follow the same pattern. Additional doors you don't want anybody to go through. The yellow doesn't say authorized persons, it just says controlled area, and the red, no entry when the red light is on. In this case, the yellow lights don't add anything to anything to address a risk, because you can't go in there anyway. So you could just have red lights saying no entry. So the problem comes with another room in the same practice where the red lights say authorized entry when the red light is on. Now, for consistency, that should be entry to authorized persons when the yellow light is on. Similarly, when exposure leads are brought outside the controlled area, rather than putting 2 pressure switches on, the engineers replace them with 2 buttons. And as the standard switch box is green and red, these tend to be fitted. But you can't do that. You can't have a red button that means make the exposure. A red button is stop or emergency stop and nothing else. So you can select anything but blue, red, and avoid yellow. So any of these combinations could be used for prep and exposure, provided that these are shrouded buttons, i.e. if you lean against them, they don't operate, so you have to physically push your finger into them. 2 examples here of unshrouded buttons. If you lean against those, eventually you'll make an exposure. Up until signs and signals regs, everybody put a bare light bulb above the door. This should be at eye level, but you couldn't move this to eye level because then it gives the risk of walking into a bare bulb. But these aren't acceptable anyway. This was a practice in Wales again, in an old warehouse, and the warning light was 3 meters above the door. And you had to be the other end of the building to be able to see the red light. So of no use to anybody. Warning lights are required to be at eye level on the door opening side of the entrance to the controlled area. again, this could be a yellow light. This is an annotated light, and the yellow is on when the controlled area exists. You can have a double box, which is blank when there are no X-rays. So when the X-rays are on, you have a red light. That's fine. A lot of practices have one of these double boxes, but only connect up the yellow half. Now that could mean to anybody coming in that there are no X-rays on. And if they're an authorised person, they can go in. It could also mean that the X-rays are on, but this portion hasn't been wired in. So if the practice does use a double light and they don't use the bottom, then it must be clearly blanked off to show that it is no longer a light. Many practices wire in both lights when the X-ray isolator is on. And this means as soon as they turn the isolator on, no one can go in the room. Just to define, this is an annotated warning light. This is an illuminated sign. So the lights are yellow and red, but the sign is black on yellow and white on red. Either can be used. The problem with the illuminated sign, and this one is halfway between the two, so the lettering on the red should be white. When I put this slide up, which was to demonstrate how the vets never need to anaesthetize, manually restrain their big cats for X-rays. They always find a reason for anaesthetising them. But I was asked why the nurse was in there with the red light on. But actually the red light isn't on. The yellow light's on and the red light's off. But you can't tell the difference. For instance, here, you don't know whether the yellow and the red are on. And also the lettering on the red has been scraped away. So in an attempt to say that it's no longer says no entry. It's slightly more obvious that the yellow light is on there and not the red. But one of my surveyors took a photograph of this room with the red light, with the lights on and the lights off, and he came back and said, I can't remember which one is which. But the easy answer to that is, well, it don't matter. It's demonstrated that you can't tell. These units can easily be modified by just a bit of window tint you can get from car factors for people that don't want to see out of their cars. But, just a sheet of this placed over the light will mean that the light is only visible when it's required, when it's supposed to be seen. Just this exercise is just to look at the color of lights, the minimum color of lights. This is an open plan area. It could be a dental with a 1.5 meter radius sphere controlled area centered on the patient, or it could be a main X-ray machine with a 2 meter sphere up to 100 kV centered on the patient again. Exposures made from within the room, well outside the controlled area, and there are people working on the table at the bottom of the room. In this case, no lights would are required, and lights here wouldn't make the situation any safer. The person making the exposure can see anybody coming in. Problem is, when they're not making the exposure, there's no demarcation of the controlled area. Some people put yellow and black tape at the limits of the controlled area. This is not the best idea, because it only means there's a controlled area when the X-ray machine is connected to the mains. So for the rest of the time in there, it means nothing. So when the X-ray machine is turned off, you still have this demarcation on the floor, which is ignored apart from a few minutes a week. Similarly, if you mark that area. The way around this is to use warning signs preventing so do not pass this point or whatever around the controlled area, so that people know how far they're allowed to go. Then once the X-ray machine is disconnected from the mains, it just becomes an ordinary room again. So the controlled area needs to be marked by signs. This is a typical one, or just a simple yellow and red, or do not pass this point is probably the best way to do it, because the operator is already in the area, and it's just to prevent anybody else from approaching. The yellow signs, various ways of mounting them. If it's a no entry or do not pass this point, then they're red and white. So the warning lights, yellow controlled area, which means authorized persons can enter. Red is X-rays on, and there's no entry. So where we have this situation, the exposure is made from inside the room. When the door is closed, we need to demonstrate what the risk is and how it's addressed. But in this case, an authorized person could go in there, open the door, and be in a controlled area. That's fine, but they don't know when the exposure is going to be made. So in this case, entry is prevented by a red light and no entry, because they never know whether it's going to be a controlled area or they're walking into exposure. In this situation, obviously the operator no longer has control over these two other doors. So they're straightforward. They need to be red lights, because the exposure is made from outside the room. When the operator's in the room, other authorized workers are allowed in. And also, once they've made their exposure, they need to go back in. So they can't have a red light there. That's a yellow one. So that authorized persons can go in and out, and nobody can go in and out of the other two doors. In this situation, it would be better to designate the whole area as a controlled area. And if instead of the lights, those doors are just locked, then no lights are required outside those two doors. And ideally, a twin light should be used outside that door. Yellow for controlled area, and red that comes on when the exposure is made. Right, so on to fail-safe warning lights. This is drawn up the main points of the guidance and IRR 17. If reasonably practical, warning lights should be fail-safe. So if a light fails, it's not possible to make an exposure. This has been argued about, and I'm not going to repeat the arguments. We'll just deal with the status quo. I'm sure there'll be discussions more later. So, yellow light, machines connected to the mains. Red comes on during prep and expose. Either light fails, no exposure. If it's not reasonably practical, sorry, you could have a backup light as well. If it's not reasonably practical, then you need to have at least two lights, two separate lights. So this is a backup. If one goes, you've still got one left, but it's not fail-safe. So some people talk about this being a fail-safe system, but it's not. It's a backup. So the consideration now is, because fail-safe lights are being produced by all sorts of people. I produce them, PLH, Burton's, a number of other suppliers, and more as we go on, we'll be making these fail-safe lights. Because I certainly can't produce enough to fit demand. Right, so what do we do? Approach one, everything's fine, we'll ignore it and fight it. Or we address the issue. It's fairly straightforward to make a fail-safe light. It wasn't straightforward designing it. But once all the work has been put in, it is a reasonably straightforward thing to do. The units I use, you interrupt the main supply by an isolator on the unit. When the unit is powered up, the yellow light comes on. And when you go into prep and expose, the red light comes on. But the exposure lead is interrupted by the failsafe unit. So that if either of the lights fail, then you can't make an exposure. Some units shut the whole set off if the lights fail, which has the end result of stopping you from making the exposure. But it's a bit elephant gun tactics to just shut the lot off, especially if you're using a CT machine. It's fairly easy to wire into the interlocks, wire this failsafe unit into the interlock so that it stops exposure rather than shutting the whole thing down, which usually takes 3 or 4 days for the engineers to get back up running again. Now with battery powered units, without the failsafe unit, you're relying on turning the lights on before doing any radiography. But the exposure lead can be brought through the failsafe unit so that you have to turn the light on in order to make an exposure. So this has the dual function of making the lights automatic and failsafe. The mains unit, with the becoming more and more popular wireless control switches, it's not possible to make this failsafe. It would involve a lot of modification to the machine, and that would have to be done by the manufacturers, and I can't see them doing it. It would cost tens of thousands of pounds to do that. And obviously for a battery powered unit, there's no way that you can interrupt exposure from a wireless exposure switch. A failsafe unit need only be fitted to the main door. You don't need a failsafe unit at every door. I've redesigned mine to be annotated lights now, but same function. For a secondary door, all it needs is for the lights to be wired in series, so that if any one of those fails, exposure is not possible. I should say that when you have two lights on their own, they're wired in parallel, so that if one blows, the other one stays on. But in this situation, they're wired in series. Or you could have just a red light. It could be a single in this case. It doesn't need to be double because it's fail-safe. But any of these combinations can be used. The actual modifications is not as bad as it looks there. On the left, you just bring mains in and out. And on the right, you just interrupt the hand switch wiring, feed that into the fail-safe unit, and then you have the wire coming out and continuing to the X-ray machine. These are excellent lights to use as warning lights. They have yellow ones or amber and red to be used in where they're appropriate. But I should say that the LEDs in these units, there's 7 of them, are wired in series. So if one LED goes, the lot go. The chances of them going are remote. They last for hundreds of years probably. I often get the argument that when you make the exposure, it's just for a fraction of a second, so the red light just flashes, and it's or it might even have time to flash. But in reality, the red light comes on when you prep the X-ray machine, i.e. that's when its voltage is building up. If it's a rotating anode, it gives the anode time to speed up, the filament is boosted, everything it needs to do to prepare for exposure. And that takes, these days, a couple of seconds, which is quite a long time for a light to be on. So the first pressure on the button turns the red light on. Now you're in prep. It may be that you're waiting for a dog to have full inspiration for a chest X-ray. So you may be waiting 5, 10, 15 seconds with the button in prep before you press the button down to make the exposure, and the red light is on throughout that exposure. It's not the case in with dental units that only have one pressure on the button. So you do just get a very quick flash. But to make them safer, because somebody is there pressing the button, preventing entry anyway, but to give more warning, the exposure is coming, 2 pressure hand switch could be used on a dental. So the first pressure does nothing apart from turns on the red light, and that indicates that exposure is imminent. And then you press the second pressure, and that makes exposure. Right, to summarise, warning lights must be relevant, conform with the regulations, mean what they say and say what they mean, be visible and easily understood, and obeyed. And I might add there, read occasionally by people. If there's interest, I'll do another one of these on large animal radiography. Sorry, warning lights and signs.